Okay, so we're on page 107. So in case 1, this is going to be a positive even function. We don't care about what's happening inside. We just know that both ends of the function go upward, right? Both ends are positive. So this is going to be a positive even exponent function. This next one, because both ends go down, this is going to be a negative even exponent function. Then we have case 2, where the left is down and up is rising. This is going to be a positive odd exponent function. And then where it goes up on the left, down on the right, this is going to be a negative odd exponent function. Okay, so this is what it means. Something that's positive even is something like 100x to the 20th. A is positive, the exponent is an even number. Something like case 2, negative even exponent function. An example of something like that would be like negative 45x to the 8th. Both of those ends would go down. These are just examples. Case 3, positive odd exponential function. Example of something like that would be, again, where the A is odd. Let's just say we use 12x to the 3rd. 3 is the odd number exponent. The 12 is positive, the leading coefficient. Down on the left, up on the right. In case 4, where it's up on the left and down on the right, a negative odd exponent function. So again, odd numbers, right? Not even. An example of something like that would be negative 1.27x to the 13th. The leading coefficient is negative and the power is odd. On 1A, it says use a leading term to determine the end behavior. So these are the different cases. Case 1, case 2, case 3, and then case 4. Use a leading term. First, you need to find the leading term, so let's just highlight it. The leading term here is 4x to the 5th. So we're going to say leading term. We're just going to call that LT is 4x to the 5th. Now, this is a positive odd function. So that's going to be case 3. So the end behavior is down on the left, up on the right. LT for 1B is a little bit different. Instead of having to multiply this out, you're going to take the multiplicities, which we'll get to in a second. For sure, you need the A. So we're just going to bring that down, -3. And the multiplicity of the first linear factor, or x plus 5, is going to be outside, it's a 1. And then the multiplicity of the second one, or the power, is going to be 3. So then we distribute that 1 to the x. So that becomes x to the first, because you're multiplying these. Because everything here is being multiplied together. We're not concerning ourselves with the constants. We don't care about that right now. And then that 3 gets distributed to the x, so it becomes x to the third. So our leading term is equal to negative 3x to the fourth. So when I want to classify this, it's going to be negative even function. So that's going to be case 2. So that means my left goes down and my right goes down. Number 2, the leading term, 7x to the fourth. So this is a positive even function. So that's going to be case 1. So that means my end behavior is up on the left and up on the right. And then in the last one, we're building the leading term, negative 6 x to the third x squared. My leading term is equal to negative 6 x to the fifth. So this is going to be a negative odd. That's going to be case 4. So that means my end behavior goes up on the left and down on the right. Page 110, identify zeros and multiplicities. You just need to know that all you're doing is factoring. It's x-intercept, 0, and root. Those all mean the same thing. So find the zeros as defined in the function. So let's go ahead and factor this. Factor by groups. Always want to make sure that you have it equal to 0. It's going to help you when you factor or solving for x, excuse me. So you're going to get factors of x squared minus 16, x minus 5, set them each equal to 0, and then solve for x. So the first one, x minus 5, is the easiest. So 0 equals x minus 5. That means that x equals 5. And then for this one, I like to do the square root property just so to encourage practice of that math. So you move the 16 over, take the square root of both sides, x equals plus or minus 4. So the way you're going to present the roots or the zeros, whatever, in a set, and you can just each individually, 4, negative 4, 5. Just make sure you count for all of them. The easiest way to know how many zeros you're going to have is based on the leading term. That's to the third, so you're going to have up to 3 roots or zeros. Now for the next one, it says the polynomial function of factor of x minus c, so that's x in some number, contains k times, where c is a 0, multiplicity is k. So let's go ahead and explain this. This right here is already in factored form, but before we get to number 4, we're going to say multiplicity is going to be, for each linear factor, you're going to have a power. So automatically we assume that you have a 1 here. So this is an odd exponent, which means that your multiplicity is an odd number, and when the numbers are odd, 1, 3, 5, 7, and so on, that means our 0 is going to cross the x-axis. The second sort of multiplicity you have is where you have an even power. So x minus c has some sort of even exponent. So because it's even, 2, 4, 6, 8, the multiplicity will touch or bounce on the x-axis. And we use touch in the class, even though it looks more like a bounce. So basically what it does, it looks like a little mini parabola on the x-axis. And then when I say it cross, like say this is your axis, your graph is going to cross, right? And then if we have something that bounces, it would be something like, so if that's my x-axis, my graph is going to come like this. It's going to cross. This is where I'm going to have x minus c to the first power. And then if it goes something like this is where I'm going to have x minus c to the second power, something even. This is considered a bounce because it's like a little mini parabola. And this is considered a cross right here, where it crosses the x-axis. Now, determine the zeros and their multiplicities. Like I said, this is already factored, which is pretty nice. So all you want to do is rewrite it so everything is equal to 0. And then you're going to take that equal to 0, this factor squared equal to 0, and then this factor to the third equal to 0. So when you write this out, it's 0 equals x, 8x to the first. So that means it's going to cross. And my multiplicity here is going to be 1. It's crossing, again, the x-axis, and my 0 is going to be x equals 0. For the second factor, 0 equals x minus 2. When you're solving for x, it's just x equals 1. Your multiplicity is 2, which means it's going to touch or bounce on the x-axis. And then for the last term, the x minus 3 to the third, this is 0 equals x plus 3 to the third, x equals negative 3. Then it's going to cross the x-axis, and then it multiplicity of 3. Because, again, remember this is odd cross, which is also odd, right? Both of these are odd. And then multiplicity is going to bounce on the x-axis. It says to sketch the function. We're going to look at the leading term. So I'm going to say, let's bring this together. This is negative x to the first power times, this is to the first power, so this is also x to the first power. And then the multiplicity on this one is 2, so it's x to the second. So I have a leading term of negative x to the fourth. So that means I'm going to have an odd even function. Remember, this is going to be case 2. All right, this was a case 2, which means my end behavior is going to be down on the left and down on the right. So what this is asking us to do in number 8, it's asking us to sketch the function from what we see. Now, sketch is going to be a very imperfect way of looking at the function. It's not a smooth curve the way you see in the calculator. A sketch is just a draft. So when we look at the roots, we're looking at the zeros. When we look at our zeros, remember we write everything equal to 0. So if I rewrite my equation, it's 0 times negative x times plus 1, or x plus 1 times x minus 3 squared. So remember, each of the factors is going to be equal to 0. So the first one is 0. 0 equals negative x, which means that x equals 0. That's my first root, or my x-intercept. We can also think of these as ordered pairs of 0, 0. The next one is going to be 0 equals x plus 1, which means x equals negative 1, or the ordered pair of negative 1, 0. And then 0 equals x minus 3, and all that is squared, so x equals 3, or 3, 0. The multiplicities of the first 0 is going to be 1. The multiplicity of the second 0 is also going to be 1, and the multiplicity of the third 0 is going to be 2. So these are going to cross, and then touch. And then the y-intercept, remember we're saying that x equals 0 and we're wanting to solve for y. So f of 0 equals -0 times 0 plus 1, and then 0 minus 3 squared. So we're going to get 0. So that means our y-intercept is going to be 0, 0. All right, so let's sketch this and let's see if we can match it to the graph on the right, which is what we've already typed in. We have 0, 0. We have -1, 0. And then we have 3, 0. And then we know our graph is gonna go down somewhere here and somewhere here. We know that our graph goes through here. Let's try a different color. Down here, graph goes through, it goes through, and then the graph bounces here. That is a mess. So it's gonna be a sketch of something like that. This, something's happening in the middle, and then a turn. And if we look at our graph a little bit more, with a little bit more intention, and we label what we know, all of those are the same. Intercepts, x and y intercepts, the roots and the y-intercept are the same. Zoom out so you can see that correctly.